The operational amplifier or op-amp, like the 555 timer, has become very common component in industrial electronic circuits. The operational amplifier is used in hundreds of applications. Different types of op-amps are available for different types of circuits. Some op-amps use bipolar transistors for input while others use field effect transistors. The advantage of field effect transistors is that they have an extremely high input impedance that can be several thousand megaohms. As a result of this high input impedance, the amount of current needed to operate the amplifier is small. In fact, op-amps that use field effect transistors for the inputs are generally considered to require no input current. The ideal amplifier would have an input impedance of infinity, with an input impedance of infinity. The amplifier would not drain power from the signal source. Therefore, the strength of the signal source would not be affected by the amplifier. The ideal amplifier would also have zero output impedance. With zero output impedance, the amplifier could be connected to any load resistance without causing a voltage drop inside the amplifier. If it had no internal voltage drop, the amplifier would utilize 100% of its gain. Finally, the ideal amplifier would have unlimited gain. This would enable it to amplify any input signal as much as desired. Although the ideal amplifier does not exist, the op-amp is close. The 741 op-amp uses bipolar transistors for the inputs. The input impedance is about 2 megaohms, the output impedance is about 75 ohms, and the open loop, or maximum gain, is about 200,000. The 741 is impractical for use with such a high gain, so negative feedback is used to reduce the gain. For example, assume that the amplifier has an output voltage of 15 volts. If the input signal voltage is greater than 1/200,000th of the output voltage, or 75 microvolts, the amplifier will be driven into saturation, at which point it will not operate. The 741 operational amplifier is usually housed in an 8-pin, inline, integrated circuit package. The op-amp has two inputs, the inverting input and the non-inverting input. These inputs are connected to a different amplifier that amplifies the difference between the two voltages. If both of these inputs are connected to the same voltage, say groundine both inputs, the output should be 0 volts in actual practice. However, unbalanced conditions within the op-amp may cause a voltage to be produced at the output. Since the op-amp has a very high gain, a slight imbalance of a few microvolts at the input can produce several millivolts at the output. To counteract any imbalance, pins number 1 and pin number 5 are connected to the offset node, which is used to produce 0 volts at the output. These pins are adjusted after the 741 is connected in a working circuit. To make the adjustments, a 10 kilo-ohm potentiometer is connected across pins number 1 and pin number 5, and the wiper is connected to the negative voltage. Pin number 2 is inverting input. When a signal voltage is applied to this input, the output is inverted. For example, if a positive AC voltage is applied to the inverting input, the output will be in negative voltage. Pin number 3 is the non-inverting input. When a signal voltage is applied to the non-inverting input, the output voltage is the same polarity. For example, if a positive AC voltage is applied to the non-inverting input, the output voltage will be positive. Also, operational amplifiers are usually connected to above and below ground power supplies. Although there are some circuit connections that do not require an above and below ground power supply, these are the exception instead of the rule. Pins 4 and 7 are the voltage input pins. Pin number 4 is connected to the negative, or below ground, voltage, and pin number 7 is connected to the positive, or above ground. Voltag is 741 operates on voltages that range from about 4 volts to about 16 volts. Generally, the operating voltage for the 741 is 12 to 15 volts plus and minus. The 741 has a maximum power output rating of about 500 milliwatts. Pin number 6 is the output and pin number 8 is not connected. As stated previously, the open loop gain of the 741 operational amplifier is about 200,000. Since this amount of gain is not practical for most applications, something must be done to reduce the gain to a reasonable level. One of the great advantages of the op-amp is the ease with which the gain can be controlled. The amount of gain is controlled by a negative feedback loop. This is accomplished by feeding a portion of the output voltage back to the inverting input. Since the output voltage is always opposite in polarity to the inverting input voltage, the amount of output voltage fed back to the input tends to reduce the input voltage. Negative feedback affects the operation of the amplifier in two ways. It reduces the gain, and it makes the amplifier more stable. The gain of the amplifier is controlled by the ratio of resistor R2 to resistor R1. If a non-inverting amplifier is used, the above formula is used. R1 plus R2 over R1. It is used to calculate the gain. If resistor R1 is 1 kiloohm and resistor R2 10 kiloohms, the gain of the amplifier is 11. If the op-amp is connected as an inverting amplifier, the input signal will be out of phase with the feedback voltage of the output. This will cause a reduction in the input voltage applied to the amplifier and in the gain. The formula, R2 over R1, is used to compute the gain of an inverting amplifier. If resistor R1 is 1 kiloohm and resistor R2 is 10 kiloohms, the gain of the inverting amplifier is 10. 10,000 over 1,000 equals 10. As a general rule, the 741 operational amplifier is not operated above a gain of about 100 because it tends to become unstable at high gains. If more gain is desired, it is obtained by using more than one amplifier. The output of one amplifier is fed into the input of another amplifier. Another general rule: the 741 operational amplifier is not operated above gain of about 100 because it tends to become unstable at high gains. If more gain is desired, it is obtained by using more than one amplifier. The output of one amplifier is fed into the input of another amplifier. Another general rule for operating the 741 op-amp is the total feedback resistance R1 plus R2 is kept at more than 1,000 ohms and less than 100,000 ohms. These rules apply to the 741 operational amplifier but may not apply to the other operational amplifier. Op-amps are generally used in three basic circuits that are used to build other circuits. One of these base circuits is the voltage follower. In this circuit, the output of the amp is connected directly back to the inverting input. Since there is a direct connection between the output of the amplifier and the inverting input, the gain of the circuit is 1. For example, if a signal voltage of 0.5 volts is connected to the non-inverting input, the output voltage will be 5 volts also. You may wonder why anyone would want an amplifier that doesn't actually amplify. Actually, this circuit does amplify something. It amplifies the input impedance by the amount of the open loop gain. If the 741 has an open loop gain of 200,000 and an input impedance of 2 megohms, this circuit will give the amplifier an input impedance of 200k times 2 meg or 400,000 megohms. This circuit connection is generally used for impedance matching purposes. The second basic circuit is the non-inverting amplifier. In this circuit, the output voltage has the same polarity as the input voltage. If the input voltage is positive, the output voltage will be positive as slow. R1 plus R2 over R2 is used to calculate the amount of gain in the negative feedback loop. The third basic circuit is the inverting amplifier. In this circuit, the output voltage is opposite in polarity to the input voltage. If the input signal is positive, the output voltage will be negative at the same instant in time. R2 over R1 is used to calculate the amount of gain in this circuit. Some of the circuit applications we use the 741 for include the level detector. The operational amplifier is often used as a level detector or comparator. In this circuit, the 741 op-amp is used as an inverted amplifier to detect when one voltage becomes greater than another. This circuit does not use above-ground power supply. Instead, it is connected to a power supply that has a single positive and negative output during normal operation. The non-inverting input of the amplifier is connected to a Zener diode which produces a constant positive voltage at the non-inverting input of the amplifier. This constant positive voltage is used to reference. As long as the non-inverting input is more positive than the inverting input, the output of the amplifier is high. A light-emitting diode or LED, D1, is used to detect a change in the polarity of the output. As long as the output of the op-amp is high, the LED is turned off. When the output of the amplifier is high, the LED has equal voltage applied to its anode and cathode. Since both the anode and cathode are connected to plus 12 volts, there is no potential difference and, therefore, no current flow through the LED. The operational amplifier can be used as an oscillator. The simple circuit shown produces a square wave output. However, this circuit is impractical because it depends on a slight imbalance in the op-amp or random circuit noise to start the oscillator. A voltage difference of a few millivolts between the two inputs is all that is needed to raise or lower the output of the amplifier. For example, if the inverting input becomes slightly more positive than the non-inverting input, the output will go low or become negative. When the output is negative, capacitor CT charges through resistor RT to the negative value of the output voltage. When the voltage applied to the inverting input becomes slightly more negative than the voltage applied to the non-inverting input, the output changes to a high or positive value of voltage. When the output is positive, the capacitor CT charges through resistor RT toward the positive output voltage. The op-amp can also be used as a pulse generator. The difference between an oscillator and a pulse generator is the period of time the output is on compared to the period of time it is low or off. Thank you for watching, and please like, share, and subscribe.